We're going to look at the question today, is x plus c, where c is some constant, a factor of a polynomial? There are a few ways to do this. The first way to go through is to divide. And when I say divide, you can either do that by synthetic division or with long division. Both ways work. Another way to go through and answer this question is use something called the remainder theorem. And I'm going to go ahead and give you an example of that next. And then the third way is to use technology by looking at a graph of a function or a table of values. So for this first example, I'm asking, is x minus 2 a factor of 6x to the third minus 19x squared plus 16x minus 4? And I'm going to show you this the first two ways. First, I'm going to go ahead and just review long division. What we're doing when we're doing this is we're taking this x minus 2, thinking and saying, is it a factor? Which means, is it a 0? So x minus 2 is equal to 0. Or what happens when x is equal to 2? So I do long division. I take the coefficients of my polynomial, which is 6, negative 19, positive 16, and a negative 4. And I want to divide by 2. So in synthetic division, the first thing we do is we bring down that 6. 2 times 6 gives me the fact that I have a 12. I then go through and add negative 19 plus 12, which is equal to a negative 7. Then I go through, multiply 2 times negative 7, which gives me a negative 14. I go through and add positive 16 plus a negative 14, which gives me a 2. And last step here is 2 times 2, which is a positive 4, which is 0. Now this means my remainder is 0. So my answer to this question is yes. And this is the way you would do it with synthetic division. But I also want to introduce what the remainder theorem here is. And what the remainder theorem says is, if f of c, and in this case we are using c to be 2, is equal to 0, then it is a factor. Why is that? Well, that's just because it says if my output of the function is equal to 0, two things are the same. Now, one of the things that we do have to be careful about is we have to make sure that we are only using a linear piece. And the actual remainder theorem says when p of x is divided by x minus c, the remainder is equal to p of a. Or when the polynomial of x is divided by x minus c, the remainder is equal to p of c. Next, we're going to take a look at what that looks like as a graph. So I went ahead and put the function into the Desmos graphing calculator, and this is what it looks like. So this is what I want you to notice when you're looking at the graph. We asked ourselves, is x minus 2 a 0? Well, what we can see when we look at this graph, if I go ahead and zoom in, we can go ahead and see that what we have at 2, meaning when x is equal to 2, it touches the x-axis. That tells us it is a factor. Sometimes it's called a root, and a 0 of that polynomial. Now, if I go ahead and look at the other two places where this touches the x-axis, I have two more. They're not whole numbers, but they still are zeros. Now, when I go through and look at this, and if you're in Desmos, you can go ahead and zoom in, and you can even touch on this. What you'll see is the other two zeros are going to be 1/2 0, that's that point on the left, and over here, it's going to be right about there, sorry about that, it's going to be 2/3 and 0. Now from that, I have all of the zeros and all of the factors of the polynomial. X minus 2, as we just said, that's x minus 2 is a root. Over here, how do you deal with the 2/3? Well, it's really saying that x is equal to 2/3. Multiply both sides by 3. And you would get 3x is equal to 2. So that would turn that into 3x minus 2 would be the other factor. And the last one we would treat the same way. X is equal to 1/2. Multiply both sides, again, in this case, by 2. And then I would get 2x is equal to 1, or 2x minus 1 is also a factor. Now, based upon the remainder theorem, I know this is getting a little messy, but what that says is all of these points are there, and the polynomial at 1/2 is equal to 0, the polynomial at 2 is equal to 0, and the polynomial at 2/3 is also equal to 0. So this is how everything combines into one place. You can, if you have a calculator that has a table of values, you can also go ahead and use that. I show how to do that in a different video.